The goal is to find the slope of a graph at any point x f of x, which is equivalent to asking to find the slope of the tangent line of the graph at the point x f of x. So again, we're trying to find a slope at one point. How do we do that when the equation for, or the formula for slope requires 2 points? So it says to find the slope, we need 2 points. However, we only have 1 point. So the trick is, look at the slope of the secant line between x f of x and another point on the graph close to that point. The idea is to move the second point closer and closer to the first point, and the closer we get the second point to the first point, the more accurate our estimate of the slope is. So what we're doing is we're taking the slope between 2 points, and then we're going to move the second point closer and closer and closer until it's infinitely close to this second point. So the slope at this point would be the slope of the graph between those 2 points. So it says, remember delta x represents the change in x, or the x distance between the 2 points. Delta x is x2 minus x1. So rather than looking at the x values as x1 and x2, we will label them as x and x plus delta x. X and x plus a little bit is what we're looking at. And rather than labeling the points x1, y1, x2, y2, we will label them x, and then how you find your y value is you plug it in to f of x, right? So your y value is really f of x. And then if you think about it, we have the second point is x plus delta x. Well, how would you get that y value? Whatever that value is, plug that into your function. So there's my 2 points right there, okay? So it says the slope of the secant line, rather than m being y2 minus y1 over x2 minus x1, well, now we're going to do the change in the y values. The first y value is f of x plus delta x. The second y value is f of x. The first x value is x plus delta x, and the second x value is x. So that's what we got these two from right here. There's nothing we can do on the top, but if you notice on the bottom, the x's cancel, so you're left with just delta x. So it says, remember, we want to move the second point closer and closer to the first point. So here's a wonderful picture of what it's looking like. So notice here here's our delta x right here. Here's the 2 points. Well, notice in the next one, all we did was took the second point, moved it a little closer, so delta x is a little smaller. And then we move that point a little closer, so delta x is a little smaller. And then we get it to where it's approximately there. So I want you to think about what's happening to the change in x. Well, we need delta x to approach the number 0. We want it to get closer and closer and closer to 0. So notice that that's what's happening. So I'm not going to lie, when I teach it with the x's and the delta x's like is done in the book, a lot of students tend to have difficulties. So I'm going to teach you the same thing another way. I'm going to do the exact same picture. Here's x f of x. But instead of calling the second point x plus delta x, I'm going to call it x plus h. And then this would be f of x plus h. So if I wanted to find the slope of that secant line right there, I would do my change in the y values over the change in the x values. So let's see that. So the slope of the secant line, let me write m secant for the slope of the secant line, would be the first one, which is f of x plus h, that first y value, minus the second y value, which is f of x, all over the first x value, which is x plus h, minus the second x value, which is just x. Notice again the x's cancel, so I'm getting the slope of the secant line to being f of x plus h minus f of x all over h. So what's the difference here? Instead of calling this change delta x, I'm just calling this change h. So when we're looking at these pictures right here and you see delta x getting smaller and smaller and smaller, what we're really looking at here is h approaching 0. So I like using f of x plus h minus f of x all over h for the slope of the secant line. This is the version that I like using, most definitely. But another version, the textbook version, would be this one right here, f of x plus delta x minus f of x all over delta x. Remember, delta x is a change in x. It's a distance here. So I just like using h. My students make far less errors when I use h. It's totally up to you. You're going to be able to do both of those, okay? But here we have the slope of the secant line, and to make it the slope of the tangent line, here's what we need to do. We need to let delta x approach 0, or we need to let h approach 0. So let's continue on the next page.